guys, yeah, so now we are going to talk about collaborative filtering. So we had talked about popularity based recommenders, and we discussed that popularity based recommenders were not the best of the world, right? Because it kind of, there are so many problems that we figure out that's there with popularity based recommenders, right? The first one being that obviously it lacks personalization, and then we had talked about the big tail problem, right, where a lot of products are not discovered yet, right, just because you're recommending things based on popularity. So that's why we need something that at least adds some personalization to your recommendations, right? So, and most important thing that probably we are going to discuss right now, and the entire most important thing we're going to discuss in the entire lecture today, is this concept called collaborative filtering. So what is collaborative filtering? Collaborative filtering is basically a very simple concept, which is, say there are two users A and B. Now user A likes a product, say M, and B also likes a product M. Now you say that B also likes a product M1, then probably A also would like that product M1, right? So this is the very simple intuitive idea behind collaborative filtering. Two users A and B like the same product. Then if now one of them likes something else, then probably user A would also like the something else. It's like the same thing that you've seen in Amazon, right? When you're buying products, so it says that if you have bought, some users who have bought this have also bought certain other items, right? So the core idea is that if it's what I've already mentioned, so I'm nowhere repeating this same thing. It's two users who have liked same thing, who are very similar to each other. Now if they are very similar to each other, now one of them actually likes something else or probably buys something else, then probably user who is similar to him or her is also gonna like or buy that same item, right? And the same thing is explained by a nice GIF out here, so which is basically there's this user, and then there's a lot of there are different products, and there's this particular video, and you want to basically see if that user would like that video or not. So what you do, how you can do that, is basically go ahead and try and figure out what are the user who's similar to this particular user, the one in question would kind of do and like, whether he would like or not like the video. And you see that, yeah, probably users similar to this particular users don't like this video, and hence you are gonna say that yes, this user is not likely to see this video. So that's the inherent idea about collaborative filtering. Now collaborative filtering are of two types. One is user-user collaborative filtering. So what is user-based collaborative filtering? User-based collaborative filtering is this concept where you say, so let's explain via a diagram. That is much more easier to do. By the way, this diagram that I'm kind of trying to draw right now is called a user item rating matrix, and this forms the basic of collaborative filtering matrices, and for a lot of that matter it forms the basis for a lot of other kind of recommendation systems. So it's nothing, it's just basically you have got user 1, user 2, user 3, M3, and so on and so forth, right? M4. Now say you have got user 1 who has liked both movies M1 and M2. Say there are 4 users and 4 movies, right? And he has liked M3 and M4. User 3 has liked M1, M2, and then say he has liked this. User 4 has not liked, say, both of these movies. Right, so this is basically one of the simpler representations of a collaborative filtering idea that I'm saying, where tick basically says that he liked a movie and cross basically says he did not like a movie, right? So simple. This is something complex version of it. This is basically where you have ratings for movie instead of cross or ticks, right? Which is basically now for easier understanding of the concept. So let's say there are ticks and crosses. Ticks being someone liked a movie, cross being someone did not like a movie. And in case of user-user collaborative filtering, you're basically trying to predict for this particular user, right? So for this particular user, U1, what you're going to try and see is that what are the users, in case you want to user-user collaborative filtering. If you want to do user-user collaborative filtering, you are basically find out similarity of user U1 with all other pairs of user, right? So U2, U1, U3, you're basically trying to figure out which are the users U1 is more similar to, right? So U1 and U4, right? So there are 3 other users, and you're going to figure out which is the user, which user U1 closely resembles his choices to. And you can probably see from this, so basically user 1 has only rated these 2 movies, right? M1 and M2. So you can only basically figure out the similarity based on M1 and M2. And based on M1 and M2, you see that user 2 and user 1 are basically very similar, right? So if you calculate the similarity score, this comes out to be somewhere around 0.9. On the other hand, user 1 and user 3 are somewhat similar. They have at least liked one movie. So this is say roughly around 0.45. And then user 1 and user 4, right? They are absolutely dissimilar. So this is say probably somewhere around 0.05. Right, so these are the scores, and based on this you see that user 1 and user 2 are very close, right? So then for user 2, he has basically liked movie M3, right, out of the unseen movies. So there are two unseen movies, right, and you have to basically predict the rating or what is the likely preference of user 1 for both these movies, right? So this is M1, M3 and M4. For M3 and M4, you see that user 1 is very similar to user 2, and based on that you can basically deduce that user 1 should basically like movie M3. So this is a concept of user-based collaborative filtering, right? So you compare different users, and based on that you figure out which is the user, which user or group of users are very similar to this particular user in question being U1 here, and based on that, whatever that group or the most similar user to U1 likes, you predict that same thing as the likely preference of user 1, right? So that is the concept of collaborating user-based collaborative system. Now there's a bit of a problem with this idea, which is that people are fickle, tastes change, and people do bad things. Now these points are basically very similar, which is basically the understanding that a lot of times what happens is whenever they consider this portals, right, say Amazon, Netflix, YouTube, there are a lot of bots or things like that which basically come and say mass vote or mass upvote or mass downvote some of the items, right? So then what happens is if you're trying to measure user-based similarity, there's a high chance that there's a chance that you would basically be matched similar to a bot, and then basically your choices would be absolutely irrelevant choices, right? So choices recommended for that user, right? It's very highly likely that the user would be treated as a bot. So in order to avoid those problems, user collaborative filtering is something that you would not want to do, right? Because there's actually a very high chance that you would end up doing that. And the second problem is that, which is basically there are usually many more people than things, right? Which what that basically implies is there are a lot of users than items, right? So on this curve, if I'm to explain you, so basically the number of users here are a lot more than number of products, right? And that happens for any e-commerce company. For example, if you think about this is the same problem that you would always think, that they would have lot more users. Say for example, Amazon would have a lot more users than the products that are listed on the website. Same for Netflix, lot more users than the movies that are being there. So in that case, if you are trying to compare user similarity across so many users, it's a lot more computationally expensive process. So that's why user similarity is awesome, but not so awesome, right? So there's something which is better, which does collaborative filtering, and yet is not so it doesn't have the drawbacks of user-based collaborative filtering. The idea on the other hand side is basically this concept of item similarity matrix. So what is the concept of item similarity matrix? Let's first understand that. So to do that, again we have to do the same thing. So you have got say two different users, U1, U2, U3, so three users in this case, and you have got M1, M2, M3 and M4, right? And then what you're gonna do is say so say this is the kind of matrix that you now have. Again, user U1 is the kind of user in context here, the one for whom we want to kind of get the ratings. So for user U1, you have the corresponding 4 movies. Again, the problem is same. He has watched these 2 movies, M1 and M2, and based on that he have to kind of again figure out what is his corresponding what would be his corresponding rating for these two movies, right? M3 and M4. Would he like M3 or M4, or would he like, which one would he like more better, right? Now to do that, what you're now gonna do is, instead, earlier you were taking U1 and pairs of different users, right? Now what you're gonna do is compute pairwise similarity of M1, M2, M3, M4, right? So you will have something like this. So M1 and obviously M1 is very similar with itself, so is M2 is very similar with itself, M3 is very similar with itself, and M4 is very similar with itself. So this is your item similarity matrix. Now you would see that what is the similarity between M1 and M2. M1 and M2 are, well, they are not so similar. There's a 50% similarity, right? So let's make M2 very similar to M1, right? So let's make this across as well. So M1 and M2 you can see are very similar, right? So say this is almost 0.9, right? And then you say what is the similarity between M1 and M3? Between M1 and M3, well, there's around 50% similarity, right? Because 50% around of it matches. Same with what is the similarity between M1 and M4. Again, in M1 and M4, obviously you have to just compare between. We are comparing only because U1 has not rated all the movies, so you can only compare based on rankings by U2 and U4, right? So between U2 and U4, you basically see that between M1 and M4, again, there's a 50% match. So let's say the similarity score between M1 and M4 is 0.45, right? 0.45, 0.5, whatever. These are some arbitrary numbers. Just keep in mind the order of the numbers. This is high. M1 and M2 is high. So is M1, M2 here. Again high. Again, M1, M2 is 0.9. What is between M2 and M3? M2 and M3 again are 50% match of sorts. So this is again 0.45 and 0.45, right? M3 and M1 we already know is 0.45. M3 and M2 we know as 0.45 again. M3 and M4, that's the last pair remaining. M3 and M4 is basically something that are absolutely again match of each other, so 1. So again we can fill out this value. So the underlying assumption is we can basically fill out this matrix first, which is basically the item similarity matrix, right? So we are doing now item collaborative filtering. So we first figure this out, item similarity matrix. Now for user U1 we have to predict movies, right? So we see that he has liked movie M1, he has not liked movie M2. So what you do is you say that what is the movie that is most similar to M1. You see that of all the movies, movie M2 is the one which is most similar. So then for user U1 you say, hey, let's recommend him the movie M1, right? So that's the idea of item collaborative filtering, right? So earlier when we were doing user collaborative filtering, we were looking at correlation between different rows, and in this case this is UU, right? And in case of II, which is item collaborative filtering, you are looking at similarity across different columns, right? So that's the idea. And now obviously this is something that is absolutely hugely popular across industry because of reasons we will discuss later. But the understanding is that Amazon, if you see this particular link that is mentioned here, you can check Netflix. Netflix also has a very important paper that came out on this, and they are extremely popular. They have been popularized by some of these big giants long back, and they're still in use quite much, very heavily in use right now as of today. So we have to now that we understand what is the algorithm, it's very simple, very intuitive, very easy to understand. There are two parts to the algorithm. Let's break them down. The first part is to get to this matrix, which is basically the item similarity matrix. Once we get there, the next part of the job is basically to figure out this algorithm, right? Which is basically how do we kind of given that there is user 1 likes basically movie M1, and user or once he also had like movie M2, right? For example, in case of say this cross, this was basically some kind of a tick. So then basically he liked 2 movies. Now how do you kind of recommend him to one movie out of his likings for 2 movies, right? Because M1 would currently give you his favorite, so the most similar movie to M1 is M2, right? And then the most similar movie, but then he has already hated M2, right? So then how do you kind of come up with this, right? So then you have to suggest him M3 or M4, both are equally likely for him, right? So all of those things, right? Once you kind of get the item similarity matrix, to finally giving him out the recommendation, right? So when he has liked or interacted with more than one movie, so how do you keep that in mind, that he has liked two movies and then you have to suggest him movies similar to both the movies, right, he has liked. So how do you do that whole process is the second part of the algorithm, right? So that's all about there is an item collaborative filtering. So now let's do this. To do this, obviously we are going to use pandas a lot, and like the way I had talked about, pandas has a lot of feature. We talked about rank feature in the last lecture. Similarly, we are going to use another feature, right? We are going to basically leverage pandas to the maximum to do all of this. So first is obviously this user versus items ratings metrics, right? As I told you, this is the one that I've been saying, U1, where you have on the rows left hand side you have rows as users, and on the top you have columns as movies, right? And user versus movies are basically this whole ratings, right? The one thing that I want you to kind of take note of this fact is this: there are a lot of nan values. What those nan values basically signifies that those are movies which are not rated by that particular user, and which is fine. Obviously we would have, obviously there are, if every movie was basically rated by every user, then we would not have a need for recommenders, right? Which would basically mean that all users have seen all the movies. Obviously we would expect some nan, but what is something that is scaringly bad is basically the fact that there are a lot of nan values, right? So there are a lot of movies which have not been seen by an user. So that's why we need the recommender system in the first place. But the problem that there's a lot of sparsity in this kind of a data set is a bit problematic. We'll discuss about what that problematic, why is that a big problem, and then how we can kind of circumnavigate that thing. But as of now, let's just appreciate the problem that there's a lot of nan, and that's about it. We'll kind of talk about how to tackle that in a later stage. As of now, you see that this is the user item ratings matrix, right? This I've got 1664 columns. So now from this we have to first come to the item similarity matrix. So how do we do that? So to do that, there are basically different ways, right? The scores that we were seeing, 0.9, 0.45 I mentioned. So there are multiple ways to kind of calculate those scores, and those scores are basically based on some ideas of distance metrics. So what are those distance metrics? Let's understand them, and basically based on that we'll figure out how we come out to the scores, right? So different distance metrics. Like, to understand different distance metrics, let's first draw out our user item matrix. So this is the different user metrics, right? So say this is again for user. Right? So say this is the two different items, M1 and M2. Now M1 and M2 are basically, so if you have to kind of represent the distance between them, let's represent this as a vector x. So this is a vector rx and this is a vector ry, right? In this case, rx is basically represented as, so if I just represent ticks as ones and crosses as 0, rx is 1 0 1 0, right? Rx is 1 0 1 0, right? In this is the column, right? So I'm representing this column M1. So M1 is represented by this vector Rx, and this is your Ry. Ry is nothing but 1 blank 1 1, right? This is R. So now if you have to compute distances between these two, similarity between these two items, right, movie M1 and movie M2, you have to compute distances between these two vectors. And how do you do that? So obviously you see that there's a missing column. Obviously you have to missing value, there's a missing column in the second place, right? So you cannot take these two values, right? None of these two. So then you are basically left with 1 1 0, and here you are left with 1 1 1, right? So now you have to calculate distances between them. So what are the ways you can calculate distances between them? The first one is called Euclidean distance. Euclidean distance is something that you are already familiar with. L2 distance, as we call it, we have seen it in clustering as well. L2 regression, it's very simple concept. How do you calculate Euclidean distance? It's basically nothing but you take pair of this, this and this, right? So and pair of this and this. So then you calculate 1 minus 1 square plus 1 minus 1 square plus 0 minus 1 square. That is your Euclidean distance, right? So that's Euclidean distance. Next up is obviously the higher the distance, the more the dissimilarity, right? So that is something that we understand. What is cosine distance? Cosine distance is Rx into Ry by mod of Rx Ry. How do we calculate that? Say we call it cosine distance. Cosine distance is 1 into 1 plus 1 into 1 plus 0 into 1, right? So you can take pairs, all the pairs, and then you take sum of 1 square plus 1 square plus 0 square into root over 1 square plus 1 square plus 1 square, right? So this is a cosine distance. So again, cosine distance, what is the interpretation of cosine distance? If the value is 1, then it means the values are very similar. If it's minus 1, that also probably means the values are similar, it's just that they're in opposite directions. If the value is 0, that means they're probably not very similar, right? So to do this, what you do is you can basically take mod of this value, and the mod of this value would basically, that value would lie between 0 and 1, the mod value, and then you can say if the value is 0, that means they're dissimilar, and the value is 1, that means they're similar, right? So the similar way you can do calculate Pearson Index. Pearson Index is nothing but correlation. So you basically treat this as x values and this as y values, and then the way, similar way you calculate correlation between two sets of values, you can calculate the correlation value, right? So nothing to talk about it. Jacard Index is basically number of matches by number of total sets. So in this case, our index is basically matched in 2 of the cases out of 3 cases, right? So J is basically nothing but 2 out of 3, because 2 out of those cases are actually values match with each other, right? So 1 1 1 1 here, but if this is the third case, the values don't match. So J equals to 2 out of 3. So that basically again is the higher the Jacard index, that basically says the higher the similarity. So now keeping in that, let's now calculate the similarity score for Star Wars. So now we have discussed the different ways of calculating distances between two items. Now let's go ahead and calculate the same. So we know that the goal that we want to get is basically calculating that item similarity matrix. To do that, let's first calculate similar movies to Star Wars, right? So let's first calculate what are the different similar movies to Star Wars. What we use is basically the correlation, right? And we have talked about how correlation is also a valid measure of measuring differences between items, similarities between items, and we see that, wow, that looks a bit weird, right? What is this movie Till There Was You something something, right? 0.87. That's got a high correlation with Star Wars, right? So you realize what we have done here, we is basically trying to get this particular thing, right? So what we want to get it is basically this U1, we have got U2, U3, U4, and we have got M1, M2, M3, M4. This is the basic starting point. From here we want to get into item similarity matrix, right? M2, item similarity is all the items on rows, all the items on columns, right? And then for this particular movie M1, which is Star Wars, we want to kind of see what is this, say in this particular, let's consider all the columns, right? What are the different columns? So what is the movie M1 similarity with other movies, right? So we have got M4. It could be the row, it could be basically the same thing, right? So these are all basically identical. So this is identical as this. So we basically want to see this column or row, whatever, basically, of movies which are similar to M1, right? And in this, and then what we end up here is we see that there are a lot of random movies which have basically come out as similar to Star Wars. Now this is something that I know based on my understanding of Star Wars being a sci-fi movie. Now, if you don't understand that Star Wars is a sci-fi movie, you have not watched Star Wars, that's perfectly fine as well. You can then take my words that these are absolutely random movies that have come up as similar movies to Star Wars. Now why is that the case? Let's first understand that. Then only we can know what happened there, and then only we can kind of solve that. So what happened here is basically there are this obscure movies, right? Movies that have been rated by, say, probably 3 or 4 users maximum, which have come out to be very similar to Star Wars. Now, why would that have happened? Because probably this movie user, say user B, who has watched both Till There Was You, and he has watched Star Wars, and he has rated both of them 5, right? So now when you compute similarity matrices between, you remember this way we calculate similarity matrices, right? So Till There Was You was rated by just this person, but Star Wars was rated by a lot of person. But when you calculate their similarity, because there's just one user who has just rated both of them, you would just measure on that user, and based on that user, you see that, hey, the user has rated both of these movies high. That means they're correlated, right? So you say 0.87, 0.9 correlation. So that is a huge number, and that's the problem that has exactly happened here. So basically, there are a lot of movies which have been rated probably once or twice or thrice, and based on those ratings and based on users who have probably also rated like movies like Star Wars high and who has rated that movie, you would basically see there are movies which come out to be very, very highly correlated with Star Wars, right? Well, frankly, there's not a problem. There could be these movies which are also actually probably sci-fi movies also. I have not watched all of them. But then there's something wrong, right? Because there's this obscure movies which are just kind of, just because of a handful of people who have rated them, this is the problem that you're facing. So what do we do to kind of counter this problem? This simple idea, right? Which is basically we just take all movies that are rated by at least 100 people, right? So that when you're calculating distances between movies, you know there are at least 100 points based on which you are at least calculating distances. So that is definitely more robust. So to do that, what we do is basically we take the data and group by movie title, get the ratings, the size as well as the average ratings. So we get the size is basically the ones that you see here, and the average rating. Now you see, this is the problem that we are talking about. So there are a lot of these movies which are rated probably once, and you've got the rating also as very high. Now obviously Star Wars would also have a very high rating, but has been rated by say 1,000 people, whereas this particular movie, which has been rated by one person, has still got a 5 rating. Those movies would basically come out to be very similar, right? So you don't want to do that. So what you do is you take all movies which have got size greater than 100, greater than equal to, which is basically means that all movies which have got at least 100 ratings. And then you do this once again, and then now you basically, what you do is you sort all the movies in order of their average rating, and you see that this looks like very familiar, right? So if you have followed IMDb or anything of that sort anywhere, you would basically see that these are the all-time favorites, right? Schindler's List, A Close Shave, The Wrong Trousers, which basically makes sense, right? Because these are movies which have been rated, which are validated by more than 100, 200 people, right? And if all 200 of them actually say that this is an average movie with average rating of 4.98, that makes sense. Now let's repeat the exercise that we had done earlier, which is finding movies similar to Star Wars. But now let's just focus and keep us restricted within this popular movies list, right? So now if we do that and we get that the Star Wars obviously is the most similar movie to Star Wars, which was something that you already would have guessed. Apart from Starbucks, you see The Empire Strikes Back, Return of the Jedi. So basically Star Wars different movies, right, are basically the ones which have been found out as the most similar movies to Star Wars. So yay, that works, right? So what we have done effectively is that now, by kind of limiting our movie sets to this movies which have got 100, greater than 100 ratings, we see that we have found decent enough recommendations, right? We have not found out recommendations. What we have done is we have been able to compute the item similarity, right? So we have found out items which are similar to Star Wars. So now that we have done that, so now what is remaining is basically to kind of do this for all movies. So we have just done for M1. Now we have to do this for all movies, and then once we do that, you remember the second part. Second part is basically kind of figuring out which movie to recommend to which user, right? So to do that, first we have to get to the item similarity matrix. That's the first step. Once we do that, we have to choose a movie and sort users who have rated movie in the descending order, and find other items from the above list of users with the help of correlation matrix, and then make recommendations, right? So first we have to compute what is the item correlation. Then once we do that, then for given a movie, we have to basically figure out what is the likely movies which are similar to that user. And once we get a list of those movies, then for each movie that a user has already seen, we basically figure out what are the movies which are very similar to that, and finally we combine them to make our recommendations, right? So the first step, as we have talked about, is basically getting to the item similarity matrix. So this is the item similarity matrix I've been talking about. So you have got columns also as items, rows also as items, right? So different items. And again, we have talked about this problem. There are a lot of sparse values, which is perfectly fine as of now. So that is item correlation matrix. That obviously is gonna take some amount of time for you to calculate if you just try and running it right now. The more number of items in your website, the more amount of time it would take for you to calculate item correlation, right? And once you do that, we'll keep it there as it is. Now what we do is basically we are trying to do movie ratings, right? And movie ratings is basically the item user ratings matrix, right? So rating matrix basically had all the users as my rows and all the items as my columns. And what we did was we basically filled all the items that were none with 0. Now one thing I want you to kind of keep in mind is basically when we did that, what we are actually trying to do in recommendation system. So that's an important thing that you should probably kind of take note at this point. What you're trying to do is basically whenever you're trying to compute say this particular thing, right? You have basically there are values which are missing. You have got ticks and crosses, and you have got, say, so if instead of ticks and crosses, let's say you have got 4, rating 4 and say rating 1, right? So you have got rating 1 and you have got rating 4 out here. So what you're trying to do by doing this, by recommending him, is basically you're sort of trying to predict rating for this. So you predict, say, probably rating for this particular item as 2 and probably 3. And then all you're gonna do is once you have basically all the movies which he has not seen, you basically predict the ratings. Then all you're gonna do for recommending is basically give him all the the ones that have a high likely rating, right? So basically for user 1 you would have M3 and 2 is the likely rating, so R cap, and 3 is the R cap, right? R M4. So this is RM3, our user 1 comma 3. So our user 1 comma 4. So this is basically the different users and their corresponding. So I comma J is basically the predicted rating, right? So whenever you're trying to build a recommendation engine, at some level you are kind of trying to predict the ratings of movies which he has not seen, and then based on this you basically predict him the movies which is very more likely to kind of watch, right? So in this case M5 says also blank, and then you see M5 is got a predicted rating of 5, or say, yeah, let's say 5. And then all you're gonna do is you say that you're gonna order the movies in the order of their likely ratings, and based on that you're gonna predict him, say M5 is the one he's likely to watch, right? Followed by M4, followed by M3, right? So that's the order in which you would likely to predict, right? So basically that's something that I want you to kind of understand right now. Not that it's important to understanding item collaborative filtering, but it's a basic concept of recommendation system that at some level what you're trying to do is basically predict the rating of different movies, right? And based on the predicted ratings you are going to try and compute your recommendations, right? So now that we know that's exactly the thing that we are trying to do, so what we are doing is basically filling out all those NaN values, the question marks, right, with zeros. And once we do that, so now let's kind of start doing the next part of the process, which is basically we find out all the movies. So movie ratings column basically gives you the list of all movies. Now what we do is for any given movie we basically figure out who are the users who have rated it the highest and users who have rated it the lowest. Once we do that, the next part of the job is basically kind of writing that algorithm to find what are the similar movies given a user and a movie, right? So you remember this, right? So what we are doing here is we have got movie similarity matrix. Now for every user, say we have to predict he has watched basically movie M1. Now movie M1, what you do is you go and figure out, given now you are predicting recommendations for user U1, right? So what you will do is you basically see that he has interacted with this movie M1, and you see that movie M1, basically what are the most similar movies as per M1, right? So you come up with top 3 movies, right, as very similar to M1. And then you look at M2. Now M2 he has also liked, but he has not liked a lot, right? So what you will have is basically this list of 3 movies from M1 and the corresponding similarity scores, right? Similarity scores, and you would basically also for M2 you would basically have 3 movies which are very similar and the similarity scores with respect to M2. Now you can see that obviously he liked M1 a lot and he did not like M1, M2 as much, right? So to kind of incorporate for that fact, you would basically give a lot more weightage to the movies that he has liked here, right? Say into 4. In this case into 1, right? Because these movies he have not liked a lot. So based on this scores, you can see the movies which are the highest at here. So now you combine this, right? So you have 3 movies from which are very similar to M1. You have 3 movies similar to M2, and you have basically now you would have 6 movies list, right? Because he has not interacted with any other movies. And based on the 6 movies, obviously the 6 could be, there could be 6, there could be 5, there could be 4, right? Because there could be movies repeated in both of them. So there could be one movie which is common in here as well as here, right? So in this case, you can take the average of the similarity scores. So the underlying idea is you would basically end up with a list of movie items along with the scores, right? And the scores being basically coming from this particular column, right? So this column would give you the scores. Now this, from this you can basically, once you have this kind of a list, then you can basically want to give top 5 recommendations or top 3 recommendations or top 10 recommendation. It's up to you. So all you need to understand is what you do here is basically for every movie that the user has seen, you basically figure out the top 3 movies which are similar to that movie, right? So in this case, first you see that user U1 has interacted with M1, so you figure out what are the 3 most similar movies to M1 and get the corresponding similarity score, right? And then similarly for M2 you get the 3, and this, instead of 3 it could be 5, it could be 10, again something that you have to decide. So you take 3 or 5 or whatever it is, and then based on those 3 movies and the corresponding similarity score, you multiply them by the rating, right? So as to give the, so as to kind of take in fact that this movie was there are movies which are very similar to M1 and you have to give a lot more weightage to them. There are movies to similar to M2 and you do not want to give a lot of weightage to them, right? Because those are not, the user did not like this movie, right? So you basically give it a lot less weightage and then you combine them. And obviously in this case you can also, you know, in case you think that this is probably not as good, you can just kind of only take those movies where the user has given a rating higher than 3 or higher than 4 and only take movies similar to those movies. So that those whole design of how you do it is something completely up to you, and that's the beauty of recommender systems, right? There's a lot of engineering into how you kind of go about building steps, and you can kind of do it in n number of different ways, right? So whatever you want to do is up to you, right? So you can kind of completely skip this whole weighting by the rating. You can just completely take just movies which have been absolutely liked by the user, right? So greater than 4 or greater than or only equal to 5, and take movies only similar to those movies and recommend them. So that's also something that you can do. You can also do this way. This is a more conventional way where you take all the movies that he has seen and find out movies similar to those movies and give them a weightage as per their rating of, so this 4 is basically the rating for movie M1 by user 1, right? And this rating M1 is basically for the movie M2 by user 2. And what you're doing at each step is basically finding movies similar to M1, right? And then movies similar to M2, and then combine them in a list and get from the similarity scores that you would have here, you predict what are the 5 or top 2, 3 most recommended movies that you want to recommend to user U1. So that's as it is, as simple, a very simple illustration of what item collaborative filtering does.
Log on to GreyAtom's learning platform to unlock more free content. Subscribe to our channel and hit the bell icon for regular updates.